Let's study 10th standard ICSE chemistry chapter 4b numericals of type 3 chemical equations. Here we'll use knowledge of the mole concept. First sum. What mass of silver chloride will be obtained by adding an excess of hydrochloric acid to a solution of 0.34 gram of silver nitrate? First step in such sums is to write the equation. So silver nitrate plus HCl gives AgCl plus HNO3. Now, the data given pertains to silver nitrate and AgCl. So we'll only focus on that. Also check, have they talked about mass, moles, volume? Well, they've asked what mass of silver chloride and they've given mass of silver nitrate. So mass under consideration right now. Always start with the molecular weights. So here we'll find the molecular weight, the atomic weights are given. Silver 108, nitrogen, oxygen, it comes out to be 170 gram. Also make sure the equation is balanced, because that will tell us a number of moles. Interestingly, it's 1 mole of AgNO3 produces 1 mole of AgCl. So no hassles there. Find the molecular weight of AgCl as well. So what this means is, when you react 160 gram of silver nitrate with HCl, it gives you 143.5 gram of AgCl. And they are asking 0.34 gram of AgNO3 will give how much AgCl? So unitary method, cross multiplication, get the value of x, and that's the final answer. Now 3.1. Equation is given in this case, I won't give in the test. The mass of copper needed to react with 63 gram of nitric acid. So copper and nitric acid, and only mass is involved here. First of all, the molecular weights. Copper is 64 and nitric acid is 63. However, be careful about the coefficients. That should also be multiplied here. So 3 moles of copper reacts with 8 moles of nitric acid. So 3 into 64 gram will need 8 into 63 gram of nitric acid. That's our data. And the data given in the sum, how many grams of copper will react with 63 gram of nitric acid? So once again, cross multiply. No need to multiply 3 into 64 and 8 into 63 because things might get cancelled. And ultimately the answer is 24 gram. Now 3.2, what is the volume of nitric oxide collected at the same time? So I'm going to write the equation once again. Let's focus on nitric acid and nitric oxide. I could have done this with copper and nitric oxide also, by the way. For nitric acid, it's 8 moles, so 8 into 63 gram will give you 2 moles of NO. By the way, 1 mole of any gas is 22.4 liters at STP, but 2 moles, so the total volume is 2 into 22.4 liters. That means 8 into 63 gram mass of nitric acid will produce 2 into 22.4 liters of nitric oxide. So the question is, 63 grams of this will produce how many liters of nitric oxide? So once again, cross multiply and get the answer as 5.6 liters. Now the fifth sum. Ammonia reacts with sulfuric acid to give fertilizer ammonium sulfate. Calculate the volume of ammonia used to form 59 gram of ammonium sulfate. So volume and mass are involved here. So write the equation. First of all, the molecular weight. Ammonium sulfate molecular weight is 132 gram and only 1 mole is being formed from 2 moles of ammonia. 1 mole has a volume of 22.4 liters. So 2 moles, 2 into 22.4 liters will form this much ammonium sulfate. The question is, how many liters of ammonia are required to produce 59 gram of ammonium sulfate? So once again, cross multiply and get the answer as 20.02 liters. Next, the seventh sum. Again, the equation is given, 2 equations are given in fact. Calculate the amount of KClO3, so mass is required, so I'll have to find its molecular weight, which on decomposition gives X volume of oxygen. So I'll have to find the value of X first. And this X volume of oxygen is the volume required for combustion of 24 gram of carbon. So I should start with the second equation first. In the second equation, they are saying that X liters of oxygen is produced from 24 gram of carbon. That is in the question. According to our information, 12 gram of carbon will produce 22.4 liters of oxygen. Make sure the equation is balanced. So it is 1 mole and 1 mole. If this was like 2, I would have to do 2 into 12. If it was like 3 here, I would have to do 3 into 22.4. Don't forget that. After you cross multiply, you get the value of X, which is 44.8 liters. That means in the next equation, I will use this value. So Oxygen, 44.8 liters, is produced by how many grams of KClO3? That is the question. Balance the equation, of course. Write the molecular weight, 2 in 2 moles. So 2 into 1, 22.5 gram will decompose to give 3 into 3 moles. So 3 into 22.4 liters of oxygen. So Y grams will give you this much oxygen. Again, cross multiply and get the answer as 163.33 gram. Next, the ninth question. Sodium carbonate reacts with dilute sulfuric acid to give the respective salt and carbon dioxide and water. Calculate the mass of pure salt formed when 300 gram of sodium carbonate of 80% purity reacts with dilute H2SO4. So 300 gram of sodium carbonate has 20% impurity. So the pure sodium carbonate out of that would be 80% of 300, that is 240 gram. So that becomes like a normal sum now. Write the equation first, make sure it's balanced. So first of all, 1 mole data. 106 grams is the molecular weight and it's only 1 mole here. That will react to give 142 gram, again 1 mole here. So the question is 240 gram of sodium carbonate, pure sodium carbonate, because 300 gram had impurities as well. 240 gram will give how many grams of sodium sulfate? No volumes here. Cross multiply and get the answer as 321.50 or 51 if you want to round off grams. And now finally the 11th sum. There's a sample of impure magnesium. It is reacted with dilute sulfuric acid to give a respective salt, that's magnesium sulfate, and hydrogen. 1 gram of impure sample gives 298.6 cc of hydrogen. 1 gram of impure sample means there were some impurities. So the question is, out of 1 gram, how many grams was pure magnesium? Then only I can find the percentage of purity. For example, if I find out that out of 1 gram, 0.319 grams was magnesium, the rest was impurities, and the purity percentage will be 31.9%. So write the equation, balance it. Number of moles is 1, 1, 1, 1. Good. 1 mole data. 24 gram of magnesium gives 22,400 cc of hydrogen. They have used cc, so even we have to use cc, not liters. So X gram of magnesium will give 298.6 cc of hydrogen. Cross multiply and get the answer as 0.319 gram. But we had 1 gram of magnesium. According to our calculation, only this much magnesium was truly there. That means the rest was impurity. So what is the percentage of the purity of magnesium? It is 0.319 upon 1 gram into 100%, which comes out to be 31.9%. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.